Hey everyone, welcome to the Incubator Podcast. I'm your co-host Darren Boyd.
And this is Sabir Saran. Thank you for tuning in. I'm really excited today to bring you a conversation dialogue with Brian Smith, CTO and co-founder at Spyderbat. Now, Spyderbat is founded in 2019, 14.2 million Series A around, based out of Texas, really focused on addressing cloud native runtime security. You think about containers and can run everything like that, you need to think about Spyderbat. We're going to get into why. But before we do that, I would really like to again, Brian, give you the opportunity to tell us a little bit about yourself before we get into the thick of the conversation here. So welcome. If you wouldn't mind sharing your background and what led you to found Spyderbat.
Yeah. I've been thanks for having me, Darren Spear. I'm looking forward to this conversation. So I've been doing security since about the year 2000. In this, I was one of the founders of Tipping Point, which was an intrusion prevention system, and we coined that term, intrusion IPS. Up to that time, people were doing these detection systems, and we managed to figure out how to put in an inline device that could actually block attacks, and that was sort of responding to the deluge of attacks, of alerts that people were getting out of IDSs. Roll the clock forward, that company got acquired by 3Com, and I stayed there for about 4 years and through 4 CEOs over 4 years. So just about the time you get something going, so a new CEO comes in and says, stop, we're going to rethink everything. And then you just go. So eventually left and was interested in addressing the attacks that we couldn't do at Tipping Point, because we would go out and talk to these advanced security firms, and they had this, sort of had the hat on of everything I can do with my technology. And they said, well, let me tell you this story. And then you get, the war stories start coming out, and came to realize that there was a lot of attack surface that you couldn't do just in the network space. Roll the clock forward. We founded a company called Click Security that eventually got acquired by Alert Logic down in Houston, and learned out of that also about more of how the analyst response, the company's response, because they were running a sort of full managed service that looked at attacks for you and helped you respond to them, and looking at the challenges based in response. And from that, I came to the conclusion that a lot of our problem is that we have really bad data and inconsistent data. There's this sort of myth that you throw all the data into the SIEM and you can solve all the problems. And what the problem's really facing kind of security analysts, and that this leads back into how you can actually prevent the problems in the first place. So it's been in runtime detection for a very long time, and have this approach at Spyderbat that I'll tell you about more, because I don't want to just tell you about it in the intro. I'll babble on from here forever.
No, we really appreciate that, and I love the history too, because it shows that you've been in the space and you've appreciated some of the complexities along the way, and I think it comes out beautifully in the product. We of course we've had a lot of exposure when you say from kernel to cloud, because you're using eBPF. And some of what that affords you from the ability to look at processes and network flows, et cetera. I think that's amazing. But from kernel to cloud was interesting. So of course, our first exposure was logically in the container space. And what I appreciated most was, I think, what's coming out in your history, which is there's some deep philosophies on how you've built Spyderbat that I think are very relevant to how people want to transact today. You mentioned the word deluge of alerts, and that's what we see, and we find that's a very polarizing approach to security, especially in a space that's dominated by ephemeral workloads and this ever-changing attack surface, which is also very hard to characterize. So I love the fact that yes, you could alert and you can alert, but converting those to traces, I do want to spend some time on. But maybe we can we can talk a little bit. If you can give us the overview, then we'll dive into some of the nuances, some of the algorithms, et cetera. I think like there's very, very cool things you're doing. But if you can give us, all right, what is Spyderbat? How does Spyderbat operate? Why is it different? I think that'd be a great place to start.
Yeah, let me answer that question by backing up just a little bit and thinking about kind of how we've done it historically. And then that kind of makes the problem kind of obvious after the fact. It's sort of if you set it up right, you sort of understand where we're going. So typically the way, and this is the way I did it at Tipping Point, and the way most alerts are detected is it started with antivirus back in the 90s. And the methodology was I figure out some signature for the attack, something that I can say, oh, that's an attack. And then I alert you on it. And the person who gets that alert has, if the attack's good enough, if it's like, this is a hash of a file that's known to be bad, which was in the very early days of antivirus, you could just shoot the file in the head and be done. So you had automated response. And then, of course, attackers evolved to make it harder and harder for those systems to detect those attacks. And gradually, we got more and more just kind of alerting. So now when the human gets the alert, what do? The first thing they have to do is establish context for that alert. Because if it were a perfectly accurate alert, you just shoot the thing in the head. You take automatic response. So it's not perfect. And so you have to establish some context. How did this thing get started? Where was it running? What was it running? What was it doing? All these kind of questions around it. The way to think about it is if you were these things monitor systems, and if you were monitoring the phone network, you might have an automated system that looks for keywords like assassinate and bomb and president. And in absence by themselves, you can't do anything with that data. You have to get the sentence, the conversation, who was talking about it, because it might be academics talking about history papers, or it might be a terrorist group plotting something, or it might be a response group trying to prevent this stuff from happening. So you need all that extra context. And the way we get that context, usually today with alerts, is you go in and you start going through your SIM or your Splunk or your data lake or something like that and asking questions and trying to piece that together. And that's this horrible manual process. And so we ended up with this in this place where we get more and more alerts coming in. Then there's this manual process of trying to respond to those. And if you get 3,000 a day, and each one takes 15 minutes to kind of run to ground, which is sort of optimistic. One guy, 8 hours a day, can do 4 an hour. So that's 32 an hour. And you have this, 100 to 1 or 1,000 to 1 mismatch between capabilities and the volume. So what you start doing is you start trying to triage all those and get the noise out before you have the context, and it's almost an impossible problem. I'm just going to ignore the word assassinate. That's kind of what we do. They call that tuning false positives. So that's, in a sense, the problem we're facing is we're trying to take all these alerts, identify them as individual things, and without any context, get rid of them. The first things that started cracking the nut on that were actually in the early days of EDR was Carbon Black. Carbon Black was just this recording device that started recording all the process and activities, and then human analysts could use that to start figuring out what if something was real and establish better context. So instead of random log messages that got gathered, it was sort of a definitive and pretty good data set. But it took an expert to go through that. Roll the clock forward, you start using that to start automating responses, and it gets better. Then the attackers adapt, and and the world moves forward. And that stuff works only marginally well in kind of cloud native Kubernetes for a whole bunch of reasons. But I think it's the right approach. So what you do is, the Spyderbat approach is, let's just record all the context across systems and link it together across systems. And so if an attack, if we see someone logs into an account on a system, runs a command that downloads the file, uploads the file into an S3 bucket. Someone over here it logs into an account, creates a cron job that then downloads that from that same file from the S3 bucket and runs it. Those are a set of linked activities. They're not all happening on one system. They're not just a process tree. It's a set of linked activities. But if you could record everything, good, bad, that was going on, then when you start taking these alerts, you can put them on that graph and figure out this caused this to happen, caused this to happen, caused this to happen. Trace that causal chain. Because it's just in the computer, you can do it automatically. And now when you're looking at these alerts, you can automatically provide context for this and say, oh, that's normal for that process to do that. It's not an attack. It's an alert, but I can dismiss that. So I can do that triage process completely automatically. And then when there's a bunch of stuff happening, I can link it together because it's all part of that same causal chain. This file was downloaded from the internet, put up on this S3 bucket, copied over here, executed by this other program. And I can find that sort of toxic combination and raise that up to. And when you do this, what you find is you don't have to turn off all that signal. You don't have to say, oh, I'm not going to listen for assassinate anymore. You'll just chain them together into conversations or groups of conversations that all involve the same principles and are all linked together, and figure out automatically that this is something an analyst can review. That reduces the volume dramatically by a couple orders of magnitude. And then what it groups things together, which is another order of magnitude of reduction, because you typically get sort of 10 things grouped together into one. And then when you actually go to investigate it, instead of those 3,000, now those 5 alerts get a raised analyst. Instead of it being a 15-minute or half-hour thing, it's like a 10-second thing to go see what the context is. And so it just kind of changes it by putting context first. Gather the context first and then use that to automatically evaluate. And that's kind of philosophically what we were trying to do at Spyderbat. And it's working really well. And there's a whole bunch of derivative things you can do that once you have that context that are pretty amazing.
Well, I think the that causal linkage visually through your living map or your behavior web is such an incredible thing to be able to traverse as well. Because to your point, like not only do I have causal linkage, I can kind of move a slider to see when some of the activities happen. That can then obviously be correlated to maybe changes in Jira or a code push, whatever it is.
Yeah.
I think being able to traverse that behavior web and report on deviations from what I've already classified as baseline behavior that I expect, I think is so powerful. I also love the fact that by using the word assassination, we're going to be flagged. We're going to be viewed by so many organizations right now on this podcast.
Well, exactly. I was going to comment earlier with our usage of deluge. We should have a word of the day where our audience actually takes a shot or drink every time the keyword pops up. But yes, we got a lot of maybe notable words or verbiage today. But Brian, again, going with that living map or behavioral web that Spyderbat produces, where in a world that context is king and context is lacking, so folks are looking around trying to make sense of the world. So once you have this map or view that you can play back as needed, what prompts a security practitioner then to actually react, because they're paying attention, but what then triggers them to say, okay, this is an event that I actually need to figure out, use the map and pay attention to, again, amidst maybe perhaps other ways. So how do you relate the right alerts with that context, or correlate the right alerts with that context, and do your job better?
Yeah, so it's a great question, because the very first thing you might think is I get a single alert, kind of like I do today, and I just look at the map. And you can definitely do that. On the other hand, it's much better to have the machine do that for you.
Sure.
So what we do is every time something kicks off that could be the beginning of an attack, just maybe a remote login from a public IP, or someone running a ping command, or kind of any sort, you can have this low-level activity, because I'm not going to alert you on it. But they're trigger events, and those triggers us to start tracing the activity. And so then we do this trace of causal activity. By that, I mean, if you think about when a web request comes into a web server, that kicks off a series of events, and maybe, a call to the web service, which then calls a couple other services, and those call a couple other services. And there's this kind of cascade of activity that happens. It's all traced to that initial causing event, right? In computer circles, that's called a trace in general. So what we do is we create traces every time there's the slightest suspicious activity. And so, like I said, we basically took the MITRE attack matrix and the Kubernetes threat matrix and wrote detectors for kind of anything that could happen on there. That's something is, like I said, just running who am I or trying to get your user ID might trigger an attack, running pingers. That then creates this trace that goes through, and as other activities flagged on that, that gives us a grouping, we call it a spider trace, that we can then create a score on. And the score is based on how significant is that activity. Running ping is a pretty low significance. Downloading a file from the internet is kind of maybe medium. Downloading it, making something executable, and then running it is probably really high significance. Doing that as root raises it to critical significance, and so on. And so I can see all these different activities. They downloaded the file. They made it executable. They created a cron job to do it. Cron job's running that thing that was downloaded from the internet and executed as root. That raises the score of that entire trace. And then that trace is what you actually get alerted on. And so it's a good analogy here is like from the medical world. If I do blood tests on you, doctors look for all these different markers, right? Maybe there's a certain set of proteins in your blood, or just high markers on some hormone or something. And it's the combination in any one of those markers I probably wouldn't alert you on, but some of them I might. But if I see a really a bad combination of those, that's what I'll alert you on. Similarly, we can create all these kind of low-level detections on things that I would never alert you on, but important signal. And the combination, evaluate both the combination and just the quantity of those to create a score for that. And then that's what we generate the alerts on. And then we'll send you a message on a Slack channel or create a case in your SIM or something else. That shows up on your dashboard. Maybe it's a message in Slack or something. You click a link and then you get just that whole trace is laid out for you. Here's what we saw. Here was the linkage of what we did. And that may span multiple systems and it may span multiple days. Yep. Because it just took a while for that thing to raise up to the score. So it's kind of like almost having this robot in the background, this intelligent system constantly evaluating thousands or tens of thousands of these traces and only alerting you when something rises to a level that we think you need to be involved.
Oh, this is really amazing. Darren, I can appreciate what you're talking about from traces when we talk about observability as a whole, metrics, traces, logs, and the traditional operational environment that developers face as well in a similar way, as well as security. Now tying that to the security context. So alerts to tracers really bubble that up to a risk score in this environment. Now, you mentioned tying this from a MITRE attack framework and everything like that. So are we is Spyderbat also getting away from traditional policy writing, right? Or rules writing that many organizations go to, and even in the domain of CSPM today, you have your out-of-the-box rules that are built on basic logic, and then organizations built other rules. How does Spyderbat take that context or that principle of rules and whatnot that's behind ultimately the alerts and traces?
Yeah, that's actually a really kind of neat thing that emerged from this whole approach. I mean, originally we were starting from just sort of make the response easier to do. And then we realized, we can automate all that kind of response stuff to make detection. Like I said, through traces. And then another thing that emerged out of this that was really cool is exactly what you're talking about the policy writing. I'm building context, this behavioral web, we call it, of everything that's happening on your system. Now I can segment that. I can segment that into it's running on Linux system, so I can do that by the Linux systemd services. This is something running on the cron job. This is something running in the mail service. This is something running in the network D service that maintains my DHCP addresses. This is something running from Kubernetes. This is running in the kubelet service, which is part of the Kubernetes thing, infrastructure. Or this is running from an image that got started on a Kubernetes server or started by Docker or what have you. So I can take this whole web, if you kind of imagine all this activity of interlink activity, and draw circles around it and say this whole group was a run of one container that started from this image. And here's another group over here that was another run from the same image. I can then digest those down to say, this is the prototype of, these are the services it talks to, these are the files it accesses, these are the processes that it goes. And I can get lots of samples of those running. We call those samples fingerprints of the container run. You can then merge all those containers together, those fingerprints together, and create essentially a baseline that's a human readable document that forms essentially a policy. So in Kubernetes, you can create these network policy objects that are kind of like the firewall rules of this service is allowed to talk to these services, and it's allowed to take incoming traffic on these ports from these external blocks, setter blocks, and talk to these other systems and so on. That's a network policy object. I can automatically create that just by observing this image talks to these other pods and and make that namespace specific. So we have that. We do that right now. That's a feature we call Guardian. Awesome. And the reason it's called Guardian is because once you do that, you can then say, install that, and anytime an image that matches that policy deviates or drifts from what it was seen before, that becomes another detection rule. And so if it'll happen that a developer changes the code so that it starts utilizing a new service. Maybe it starts using Dynamo in AWS all of a sudden, or a different S3 bucket. I can detect that happens and create an alert on it if it's running in sort of the dev environment, and then you modify the policy and move on. Or in the production environment, you go and say, I'm going to both create the alert and kill the pod or kill the container or whatever, and go back to this automated response. And then the reason, does that make sense? I'm not sure if I'm...
No, it absolutely does. And what I enjoy about that too, though, is so this is Guardian, which is important. And it's important because you touched on something else. We're talking about behavior and we're talking about deviation. And that, of course, has a security context. But it also, what I enjoy about that is it fits into a build process in an SDLC. If a developer, to your point, is changing the fundamental behavior, I can see that. And we know there's a massive asymmetry between developers and security practitioners. And I can elect to flag that potentially long before it gets to production, if I so choose, because now I can see these deviations. And then, of course, when things are running, I can check this in real time to prevent attacks. So I love the idea of Guardian being able to help all the way into a development process. I love the idea of Scout being able to say, look, regardless of what your policies are, there are things we just know are bad. And being mapped to MITRE, we can take care of that as well. So I think that's because when you open the conversation and we were talking about SIM, there's some drawbacks on SIMs in that, I have to look at my IOCs and I have to codify these rules and they have to be specific and now they have a life cycle unto themselves. But what you're looking at is so much broader than that, and being able to do these traces. I can do things that I just can't do with static rules necessarily, and it's on an ecosystem level. Like when I first evaluated Spyderbat, I looked at it from this is going to help our developers. This is going to help our security practitioners get early and make sure we don't have unwanted behaviors. But when you tie that into an ecosystem, this is a very powerful map.
Well, I think it's what's really neat about it, and we're continuing to develop this, but we're already seeing at customers a really neat ability emerged where the development group is able to look at this and say, this is my application. I know how it's supposed to behave. The security group comes in and says, this is what we're seeing from the runtime behavior. Does this match? And they say yes. That can get checked in as literally code. It's just a YAML file that describes this thing. Now, when there's drift happens in the developing group, right now it comes in as essentially an alert, like a Slack alert. But we're working on just adding in the connectivity to be able to open it up as a GitHub issue to the developer, that they modify the code so essentially it just come in as a pull request of saying, we see this new behavior, here's what we think the code changes to, edit it, approve it, edit, look at it with human eyes. That same policy then, that same described behavior that the developers looked at and said, yeah, this is the way it works, can then be used by the security group to implement policy in the production environment. So then when the developer changes that, they have this automatic communication mechanism between developer and the production environment that's kind of seamless, and it doesn't require like endless code reviews between the developer and the security group getting in the way. It just kind of seamlessly flows through. The other thing that we're doing as a dimensionally is, if you think about the context, we've been using eBPF down at the kernel level to figure out what processes are being executed and what network connections are happening, what files are being accessed, and all that kind of baseline behavior. That goes into our analytics system that builds this behavioral web and all the things that derive from that. We're gradually adding in more and more things to gather context. For example, we're working on technology right now that leverages some of the ideas from the Pixie stuff that is the Kubernetes Pixie project that can do layer 7 decode. And this way we can do API discovery. So rather than saying this process is talking to S3, this process is doing these operations on this bucket on these objects, and that's what it's allowed to do. So if that process gets popped and starts trying to do other operations on other buckets to do, even that minor level thing becomes a drift within the application.
Yeah.
And so once you start going down this path, you're not looking for, I have to research and figure out what the vulnerabilities and the O-days are in the application. And then that's what I track, because I don't know what the O-days are in the applications that I've written. If I knew it, they wouldn't be there. Right? Instead, I'm just looking at these behavioral changes, and that becomes a much better detector than trying to detect someone exploiting a vulnerability that is known. You know what I mean?
Yeah, I love that.
Especially in custom apps. No one's doing research on your custom app to try to discover O-days. It's
correct.
Just not happening.
Well, the other aspect of this too, Brian, maybe you could talk on this as well. This is a hard one to get right, I think, but not only can you go to the causality path, you can do preventative. You have some enforcement capabilities. And again, I think it takes a long time for an organization to start to go to that side of things. But can you briefly describe how much further you can take this if someone elects to go down an enforcement path or a corrective path, because Spyderbat enables?
Yeah, so if you have this whole behavioral web, you can classify the world of that behavior into known good, known bad, and kind of that's weird. That's weird you have to have humans ultimately look at, but we can triage that down so that you're only looking at kind of significant stuff, and then do suppressing that so that you only look at that particular bit of weirdness once. The known bad comes mostly out of the this Guardian policy type things, because what you do is that the normal process is you just deploy your images, and Spyderbat's running on that Kubernetes system, and it's constantly building fingerprints for every image that ever runs anywhere, right? And then there's two things you can do. One is you start building these profiles of the images, and it takes like 10 minutes to build the initial baseline profile of an image, and you put that in audit mode. And you just kind of let that run for about 2 or 3 weeks to make sure that there's no new deviations that show up. Maybe, once a week a backup kicks off, and that's a new behavior that we didn't see. So you incorporate that stuff into the baseline, and the human reviews it. And then after that, you can turn it from this kind of audit mode where you're just tuning it and validating that policy into an enforcement mode. And that takes, classifies, this is everything that's within that bucket is known good. And everything that occurs from that image or containers, from that image or in that service that are not in the known good is known bad. And I can start in production environments, I can just start killing the pod, killing a process, all the way to running custom scripts that are in your environments, which might involve, I don't know, restarting a whole service, which is or other types of things. Then at the broader level, as you begin to lock down the system and begin to identify this, you can also start greater rules like these images only from this repository can be run, and any image that started outside of this that didn't come from one of my approved repos is killed. Any process that's talking to not the local DNS server that's one of my approved DNS servers gets killed. And so you can by the key that we learned from the tipping point days is in order to be able to take fully automatic action, you have to have really, really high quality and high confidence in your data. And the Guardian stuff in particular, once you've gone down this path, and it's not a hard path, it takes literally maybe 15-20 minutes per image to do, and then it's a very slow 5 minutes a week maintenance process, gets you targeted enough, confident enough stuff that you can start taking the automated action. And you can kind of prove it out to yourself because you run an audit mode, which is dry run mode, where it says we would have killed this and we would have. And after you see 20 or 30 decisions in a month where we haven't made any mistakes, you get confidence to turn it on and say, okay, I'm going to go into automatic and I'm not going to kill my entire environment because of a bad thing going on. It's that's the process, and it works pretty well. We've have a lot of customers that have locked things down and prevented pretty nasty stuff from happening.
So Brian, amazing kind of domain you're addressing here. Can you speak to where now Spyderbat is actually, I guess, moving from a product roadmap vis-a-vis a little bit of we get the problem area that you're solving for, which speaks to the current landscape from a competitive standpoint. What's exciting for you for Spyderbat here in the near future?
So it's a good question. It's a couple different things. One is, as I alluded to earlier, we started with this, essentially process machine level context. We're going adding in the layer 7 context to be able to decode layer 7 messages, and this will allow us to do things like API discovery, as well as more granular controls on this. Like as I was alluding to earlier, this process, it can't just access S3. It's allowed to do these operations on this bucket. As we do that layer 7 decode, that or similar, you can do very similar things on like database APIs. This application does these sorts of queries on these tables in this database. If it tries to do select all, describe tables and select all from every table, select star from table, that we can block those sorts of things. We can detect and block those sorts of things. So it allows us to go more into the layer 7, the application level, both discovery and enforcement. But then you link that in with the cloud and all the control plane APIs, be it cloud APIs or the kube control, the Kubernetes APIs or the Docker APIs or containerd API, the container runtime APIs. We can take the audit logs from those things, in AWS, for example, CloudTrail logs, and I can tie it back to actually the network call of the process that did this, and get that to be able to do detections at that level and enforcement of policy at that level. So if you think about one of the attack paths, if I pop a process or a container on Kubernetes, the first thing I'm going to probably want to do is try to see if I can access the control plane, bounce up into the control plane to do something to the data plane, and then move back into the data plane. And you get this dance between the control plane and data plane. So we're building out all those capabilities, and probably by November-ish this year around KubeCon, we'll be announcing a whole raft of new capabilities around that. And gradually, that's going to be the pattern. You gradually enhance context. That enhances our ability to build a richer, deeper web, which gives us more ability to do more granular policy discovery and more granular kind of understanding of your environment, and just kind of lockdown and characterization of your environment.
Awesome.
My ideal world would be we can so easily characterize environments that, and the thing to understand is server environments are not like desktop environments. They tend to do a small number of things and just do them over and over and over again, and they can be pretty well locked down. If you can characterize and understand that stuff and get it so that 99% of everything that happens up there is in this good category, then detecting attacks becomes really easy and very accurate.
This is a very powerful value proposition that Spyderbat has as cloud adoption, container adoption goes forward. And obviously, security's always overburdened, as traditional operational folks are. Yeah. So you're really trying to make effectively put a dent in the operational burden, at the same time improve the security posture. One final question I might have from kind of this vantage point that exists out there, where maybe there's a thought process that you had the traditional SIEM where everything was fed into the SIEM. Then now you probably have some aspect of things just being consolidated into a CSPM, and hey, we're just doing this all within the CSPM platform and single screen and single pane, versus a point-specific solution like Spyderbat. What's your just general take on that dynamic that exists out there? Because I do believe that just the CSPM is just another manifestation of let's call it a SIEM for cloud. If I dumb it down, and you're still having the alert deluge going on there potentially unless you write all the policies and the rules there. But would love your take on it.
Well, if you think about security as just very large, there's basically two areas you can think of. One is all the preventative things you can do pre-attack. So encrypting your data would fall into that category. Strong authorization, identity and access management would fall into that category. Good architecture would fall into that category. Vulnerability management, least privileges, zero trust architectures, all that falls into that preventative end of the universe. And CSPMs, largely fall into that. They're about managing your posture in the cloud. So making sure that your implementation of these preventative controls is adequate.
Yeah. So just to interject there, Brian, and maybe, I don't know how many organizations have gone to that preventative side of things, and there's still on the detective side. And tell me what is wrong with my posture. And again, it stems, and then just more operational burden at the end of the day for people to go out and fix it, versus preventative is the ideal state.
Well, it's those sorts of things like vulnerability scanners and things that scan your code base, Dependabot and GitHub and Sneak and any of the vulnerability scanners are like that. They look at your existing environment, your existing posture, CSPMs, and say, well, this is wrong and this is wrong and this is wrong, and then you try to fix it. And the problem with that is that it's all good to do and it sounds great, but it's also vulnerabilities in software are just bugs in the code that can be exploited for security, that have security implications, right? And so eliminate all vulnerabilities in the code, known and unknown, is kind of like ship code that has no bugs and not just no known bugs, also no unknown bugs. And I mean, I think we know how that's going to work out. And in theory, maybe it's, in an academic, as Yogi Berra said, in theory and practice are the same, and you can do it. In practice, it's different. Theory and practice aren't. So a more pragmatic approach is to think about the two playing off each other. The CSPM or the vulnerability scanners tell you the list of the 500 vulnerabilities you need to that are potential attack vectors. The runtime detection stuff is a really good focusing lens to say these things are actively being exploited by these actors. Definitely fix those because you want to get out in front of it, but also use the runtime stuff to provide a mitigation strategy to block their attack, to slow them down, to stop them in their tracks, so that then you can go do the preventative side. It's not an excuse to get out of ever fixing your stuff.
Yeah.
But it is a focusing lens that rather than these 500 things, here's the 3 things that should be right at the top of your list.
Yeah.
And so it goes from theoretical vulnerabilities or potential things that probably will never get attacked, or you have to figure out how to prove that they never can get attacked, to here's the stuff that we're blocking for you right now, but you really should fix this stuff.
Yeah. Well, thank you for driving and clarifying that point here. And Brian, really a pleasure having you here today on the Incubator Podcast. I think this was a valuable discussion, really a different way of looking at runtime security, and looking forward to your success at Spyderbat.
Yeah, no, I think thanks for having me. I always enjoy talking about this because I after doing this for 20 years, and working on different products, I think we've got a way that we've really kind of cracked the nut on this thing. And I'm really interested to see how this evolves. It's evolved in ways that I haven't imagined, and it continues to kind of amaze me as we go forward. So it's a lot of fun.
Yeah, no, we really appreciate it. I'm going to leave it on kernel to cloud, alerts to traces, causality through enforcement, a really interesting platform to look at. And we appreciate you coming on the show.
Yep. Thanks. And, one little plug here, if people are interested in it, you can just download it and try it for free. A lot of security companies try to put you behind a wall where you have to talk to a salesman and, sign a non-disclosure agreement before you can even figure out what they do. I just want people to try this and see what it's like. So it's free to try, free to download, free to use, up to a scale where you start costing us a lot of money to do all the monitoring.
Sure thing. And again, for our audience, if there's any questions, feel free to reach out to us, and we'll put you in touch with the right folks at Spyderbat. Thank you all.
Cool. Thank you. Have a good day.
Bye-bye.